1, input is D, 2. Now we just repeat that. Yeah?
Yeah.
Cool. Alright, so that was the easy one, right? Alright. Do you remember what the first step was to convert from a DFA to add another initial and final state with anti-stream transition, right? Yeah, so let's do it. And call this stream. Take out the final state here and have a transition. Or final state. All right, we have to eliminate one of these two, right? Which one should we do first?
2.
2? Okay. Okay, so from 1, you can go all the way to F, right? If we want to go from 1 to F, we have to B, right?
Yeah.
We need a B. What else? Is that all? No.
And then B
Any
goes
number
back
of
to
A's.
1.
And any number of 8, right? Yes. Okay. Have a look. All right. So this one and this one are gone. Oh, we forgot the entries. Now there's one transition here, this B, that comes back to 1. How do we handle that? What is the path that I need to take to use this transition here to 1? I need to go from 1, go to 2, and then back to...
Is it the U, like the or?
It's going to be a loop.
So yeah, like the U, right?
Well, the union
Yeah.
of what with what?
That look like Bay Union. B.
All right. If we need to go from it's basically a loop because we're going from 1 back to 1, right?
Mhm.
So to eliminate this guy, we're just going to convert that into a loop in the regular expression, right here. Okay. So essentially, we can go from 1 straight to the final, the accept state, and from 1, you and come back to 1. So what would be the transition?
B, A, King star, B.
Yeah. Okay, I'm gonna put the empty string here. I don't like it, but I guess John taught you this way, right?
We need it at the front.
Huh? Sorry?
Why do you need it in the front of it?
Oh, yeah, not yet. But I do need a. Do I need it here? No. Okay. All right, now we just have to remove the other one, right? All right. We're gonna have one single position. Where do we start? Right. Now with the empty input, it's gonna be 1. How many? Oh, there's one other step here that you can do before actually doing this one. Can you see what? We can simplify this guy a little bit. Yeah, we have these 2 loops here. We can just put them all in 1. So we can.
Like A, King star, union, B, A, King star.
Yeah, it's gonna be.
Shouldn't we going to see? Or no?
Just double check. Yes. You need a marker. There you go. Okay.
That should be all from Q to King star.
Yeah. This we're not gonna do it now. Oh. Can you see it from back there?
No.
Then yeah, then. Okay. Let me just rewrite this. So we're gonna eliminate this. Oh, nice. So we're gonna eliminate that one. We're gonna combine with what was it? What was it?
B, A,
B A star, right?
Is that supposed to be a union?
B.
B star B. Yes, this would be the union of these 2
I think
transitions.
you gotta put the U.
Huh?
The U's plus sign.
It's one or the other, right?
That's the U. You don't
Sure,
use plus
that
sign.
works as well. It's the same.
It means
Is it not? What does the plus sign represent in a regular English?
Say, look, I don't want to put the plus sign because then we have what grade?
Huh?
yeah, it is.
Yeah,
Here?
Yeah,
yeah,
because it's a loop.
it's different.
Yeah. It's underneath this. Later. It's not mine. There you go. Okay, cool. Now to the last one.
So you're just doing
So from S to F now.
So then you put what you got in red.
Wouldn't you just like doing union with them?
Yeah. Well, it's either any
Yeah, back.
any of these as many times as possible, and then it has to have this one again, right? So string A yes. Oh no, it's not a star here. Not yet. No, you're gonna see it. I can either do this loop by doing a single A, okay, or by doing B, A star, B once, okay? So no star here yet. There will be another star, which is, well, this loop itself, right? And and then concatenate with that. Yeah? All right. Where's John?
There are PA and PB. And what it's saying is that I'm going to have to subdivide this string into parts, X, Y, and Z. I'm going to have to break it apart to where when that gets broken down, when I split them up into the parts, that the following three rules will be true. Let's start from the number 2 and 3 and then end up on 1, okay? Number 2 says that the length of Y has to be at least 1, right? It's saying that the length of Y can't be the empty string. Can X be the empty string? Sure. Can Z be the empty string? Technically, yes. So Y has to have something in it. The other one is part 3. The length of X and Y together has to be less than or equal to what? P.
So the only one that can prove this one is equal to P.
Well, let me get there in a little bit. Let's finish the application real quick. I have to subdivide this. I have to give each section a different part. So we've got X, we've got Y, we've got Z. The length of X, Y together has to be less than equal to P. And Y has to contain at least one thing. Somebody make an observation for me. What is it?
You can make Y out of P and X empty string.
Yep, absolutely. Y could just be an A and X could be empty string. X can be a bunch of A's and Y can be an A. Y can be all of the A's. Somebody make an observation. What can Y never be?
Zero.
Can never be of length 0. Absolutely. What else could it be? Can never be an empty string.
Never be negative.
Never be negative. It can be 1A, 2A, 3A, 4A, 5A, 6A, 7, all the way to PA.
It would be more than
Let me ask you this. Is it possible for Y to contain a B? Is it possible for Y to contain a B? What is the length of X and Y together capped at? Can't get any higher than that. It cannot go higher than P. And then X and Y have to be in order, right? It starts with X, then Y, and then Z. And the length of X and Y together cannot exceed P. Good. Cannot. Yeah, that's the observation. Good, good. Yeah, that's the observation. So can Y ever, well, I could make X P A's. All of these will be X. But Y would have to be over here, and the length of X, Y, if I had 1B, would then be P plus 1. Can't do it. Why not? Number 3. Cannot do it. So Y can't contain a B. Ever. Never, never, never. look at here, these are all the things it can be. Whenever we break it apart, think about all the things that X can be. X can absolutely be the empty string. And then Y could be a single A, and Z could be everything else. Let's try this out and say, let's look at what the pumping lemma says we can do now. Okay? The pumping lemma says that if we choose a string S from the language A, and I chose this one, A to the P, B to the P, A to the P, B to the P, then that string, if it is regular, should be able to be subdivided into three parts, X, Y, and Z, such that the length of Y is always, it at least has 1 in it, and the length of X and Y together is going to be limited by P. If we can subdivide it that way, then we should at least have one where we can increase the number of instances of that Y subdivision, and it's still in the language A. Let me show you what it looks like for this very thing, okay? We'll get there in a second, Victoria. All right, so when we get to this very thing, let's look at what happens when we do what's called pumping. This right here is where we do the pumping. If we have this subdivision, we have X, Y, and A, B, 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 B. So here we have 0, 1, and 2p minus 1 in length. If I increase the number of y's here, this is when y is equal to just, when I is equal to 1. This is exactly 1y. I want to show you what happens when we set it up to be I is equal to 2. When I is equal to 2 on this part, x, y to the I, z, it says we're going to take the x and we're going to increase the number of instances of y to 2, where we have A. And then we have the same number of things here. We have A. To be clear, there are PBs and P minus 1 A's there. Is this string inside of the language A? Yes or no? Strong yes, strong no. What is it? Is this in the language A to the N, B to the N? Let's look at it this way. 1A, 2A, P minus 1A's. This is P plus 1A's followed by PB's. It's not. There's more A's than there are B's. In fact, if I did it like this, I equals 7. This would mean that X is going to be the empty string. Y is going to be 7 A's. A. And then the same number of A's and B's after that. See what A is, no, I'm not going to do it right now. That'd be complicated. Because I'm thinking of the way I was going to write it, and that'd be complicated itself. No way of doing that. All right, can only contain A's. Therefore, pumping up will result in an increased number of A's without increasing the number of B's. Resulting in a string not included in A. Thus proves A is non-regular. Now I know y'all might feel somewhat comfortable with that. That's because you're still in this room. When you leave this room, 5 minutes from now, you might have a question or two, and that's okay. All right? But I want you to read that, and I want you to throw any questions you have at me. Carter.
So you asked us earlier, like before this class or like the class, but prove that A and B was a language, correct? A regular language?
Mm-hmm.
So that was a trick question? It's
Absolutely.
Not,
Yes.
Just
Yeah.
clarify.
I was a very safe bet. If I wasn't sure, 25 cents, like max on the reward, all right? Maybe like an expired Sonic coupon, all right? But it's, with $1 million, you can believe that I knew that the answer was that you could never solve it, for sure. Exactly.
So how would you prove that new number of A and new number of B is regular?
That's important. Say it louder, because I don't think everybody can hear you.
How would you prove that an even number of A's and an even number of B's is regular using that?
It's a very important question. To prove that a language is regular, we try to what? Build a dictionary that accepts it. If we fail, doesn't mean anything. Doesn't mean anything. If we want to prove that it is non-regular, what do? We apply the pumping limit. And if we fail, what does that prove?
It's a DF. It is regular.
That's the breakdown. Just like if we fail to build a DFA, it doesn't prove that it's non-regular. If we fail to apply the pumping limit, it also proves non-regular. We just throw something else. So this proves non-regularity. DFAs prove regularity. That is such a key question, and I hope everybody understands that. This proves non-regularity. DFAs prove regularity. Failing means retail job. Right? Exact example. Okay, I'm going to leave this up here just for now. Oh, excuse me. I'll erase it when it becomes irrelevant. Okay. Let A be the strings W such that W contain an equal number of A's and B's. Using this essay as a template, using this as like the general direction, I'm going to leave it up here to remind you where we're going. Let A be the language where it contains strings W such that W contain an equal number of A's and B's. And try to prove non-regularity. I'll leave the bottom as an example of what you might, the direction you might take. You're feeling good, right? an equal number of A's. So the number of A's is equal to the number of B's.
Yes, it could be.
Isn't that what you just kind of?
What do you say, Hannah?
Isn't that kind of the same thing as what you just did?
No, if you
I'm
could
gonna
have,
say
like,
because as you increase A, you're not gonna increase B, so.
Hannah's asking.
ABA.
Hannah's trying to be nice about asking me something. Like she's trying to say, do I have to change a damn thing? Is what she wants to say. Do I have to change anything about that proof?
No.
No. It is the same thing. The language A, where it contains strings that have an equal number of A's and B's, like the string A to the P, B to the P. The string S, where it's A to B, is in this language, right? It's in that language. Good job. Leah and Hannah nailed it. This doesn't have to change at all. The string S is in the language A. I just proved it, same way. Mm-hmm.
But that doesn't say they can't alternate A's and B's.
It doesn't. It absolutely doesn't.
So I can build a DFA for that.
I would give you $1 million if you could.
Does it not just have your first note and A leads to the next and then B back?
If you tried it 1,000,000 times, you won't be able to solve it. And I know it. I know it. I know what you're thinking. That's why I love this example. You want to say this is closer.
What A on it because the DFA requires method reference, so you have to be a loop, right?
There has to be a loop somewhere. That's actually in the theory behind the pumping lemma works. But the pumping lemma says this. If the language A, that language, is regular, then for any string S that I pick that is bigger than P, that is in the language, I'm going to choose this one. A to the P, B to the P. Why? Because it said I could pick any string, and I'd already written this crap. So I just wanted to be done and go home and get coffee. Done. I chose the string A to the P, B to the P. Because that string is longer than P, and it's in the language, and now I start doing these restrictions. And I love what Jeremiah is doing so much right now. I love it because he's challenging it. Outstanding. All right? But it does work. It's the selection of S. Once you get to S, you're done. The rest of it is just how we write it out. All right? Questions?